Hello, my dear students of 6th grade primary school. Today you will have our first lesson or our first episode about science program. I wish you every possible luck. I wish you a happy new school year this year. And now we will start our first lesson about the difference between math and wit. Already we have studied the concept of math in 4th grade primary school or in primary 4, and we studied all the properties of math in this year. Okay, so now we want to differentiate between math and wit. عايز افرق ما بين الماث والwit. موضوع بيعمل confusion كتير جدا بين الطلبة. What's the difference between math and wit? What's the difference between math and wit? So now let's start our lesson to know the difference and all the properties of math and all the properties of wit. Okay, now let's start. So we can see that sometimes we read the sentence net wit 5 kilogram on some bags. احيانا بنشوف كده على بعض الحقائب او بعض الاكياس مكتوب net wit الوزن الصافي 5 kilogram. Net wit 5 kilogram. الكلام ده صحيح? I think it's not true. I think it's not true. Why? Because net wit or wit is measured by a unit called Newton, but mass is measured by a unit called gram or kilogram or ton. So again, we cannot measure wit by kilogram or gram. So now let's start the difference or the definitions of each one of them. Is this sentence true? Again, net wit is 5 kilogram. يعني الجملة دي صحيحة. طبعا خطأ جدا. ما ينفعش أقول الويت بال 5 kilogram. But we can say wit is 5 Newton as we can see now in this lesson. So now let's study the difference between mass and wit. At first, what's meant mass? What's meant by mass? What's meant by mass? إيه معنى mass أو إيه definition الخاص بmass? Mass is the amount of matter in an object. Again, mass is the amount of matter in an object. Again, for the third time, mass is the amount of matter in an object. الكتلة هي كمية المادة الموجودة في الشيء. Again, mass is the amount of matter in an object. What are the properties of mass? إيه هي خواص الماس? We have studied mass in primary 4, but now in this year in primary 6 we will study mass in detail. هدرس الماس بالتفاصيل أكتر. At first, mass increases when the amount of matter increases and vice versa. Again, mass increases when the amount of matter increases and vice versa. Imagine that I have a bag. نتخيل مع بعض. I have a bag. Look here. I will draw it. I have a bag and I put it a marble. This marble is 5 grams. Okay. So what happened if I put another marble? They will be 10 grams. Okay. Another marble, they will be 15 grams. So what happened? What happened to mass when matter increases? Again, when the matter increases, mass increases too. يعني لما الماس أو الماتر increase الماتر بتزيد الماس برضه بتزيد. وده بنسميه زي ما خدنا في primary 5 last year direct relation أو علاقة طردية. So again we can say mass increases when the amount of matter increases. Again, we can say mass increases when the amount of matter increases and vice versa. What's meant by vice versa? Vice versa means when the amount of matter decreases, mass decreases. Again, when the amount of matter نغير اللون شوية عشان ناخد بالنا. When the amount of matter decreases, mass decreases too. So they are with the same meaning. ليهم نفس المعنى تقريبا أو نفس الريليشن عشان كده بسميها direct relation أو علاقة طردية. So again, the relation between mass and matter is direct relation. So it means that when mass increases, matter increases. When matter decreases, mass decreases, and they are the same meaning. يعني الاثنين بيزيدوا مع بعض أو بيقلوا مع بعض. So I can say again, when amount of matter increases, mass increases. When the amount of matter decreases, mass decreases too. So again, the relation between mass and matter or matter and mass is directly proportional or direct relation. Another property of mass, all matters have mass whatever their physical state. Again, it's a very important property of mass. All matters, كل المواد اللي في الدنيا have mass whatever their physical state, solid, liquid or gas. What happened? Or how can I understand this property? Imagine that I have an ice cube. Okay, I have an ice cube like this. نرسم مع بعض. I have an ice cube. Its mass of this ice cube is 50 grams, for example. Yeah. Okay? What happened to this mass if this ice cube melts? What happened if this ice cube melts? I think the mass will be 50 gram too. 50 gram too. It doesn't change. So again, all matters have mass, whatever their physical state. Whatever their physical state, solid or liquid or gas. So again, when the mass here is solid, it has 50 gram. When it will be liquid, it's 50 gram too. So what happened to mass? Mass doesn't change by changing the state of matter. Again, mass doesn't change. الجملة دي مهمة جدا. ممكن أقول mass doesn't change. وبصراحة بعد أهم حاجة في الماس، يعني الماس doesn't change دي أهم property في الماس. Mass doesn't change by changing the state of matter. Okay? So again, all matters have mass, whatever their physical state, solid or liquid or gas. Again, all matters have mass, whatever their physical state, solid, liquid or gas. Or we can say that mass doesn't change by changing the state of matter, or we can say also all matters have mass, whatever their physical state, solid, liquid or gas. يبقى لو في مادة solid عندها mass معينة, for example 50 gram, if it changes to liquid it will be 50 gram. If it changes to gas, it will be 50 gram. Why? Because mass doesn't change by changing the state of matter. يعني مهما غيرت حالة المادة من solid ل liquid, من liquid ل gas, من gas ل liquid أو من liquid ل solid, mass of matter doesn't change by changing the state of matter. So another property of mass, what it will be? I think it will be all matters have mass whatever their place. كل الماترز عندها mass مهما كان مكانها. يبقى البروبرتي الثالثة للماس all matters have mass whatever their place in hand, on the earth, on the moon or on any planet. Again, all matters have mass whatever their place in hand, on the earth, on the moon or on any planet. So we can imagine that. تخيل ان somebody is standing on the earth. نرسم مع بعض earth, okay? And we know that earth is much bigger than the moon. This is the moon and this is the earth, okay? Someone standing here on the earth, okay? His mass equal, for example, 60 kilograms. So what about the same person, or what about the mass of the same person on the moon? I think it will be 60 kilogram too. Why? Because mass doesn't change by changing the place. يبقى نقطة مهمة جدا. في ناس كتير قوي كان بيحصل لهم ميس اندرستاندينج في الموضوع دوت. بتخيل ان عند المون بيحصل decrease في الماس. No. Mass doesn't change by changing the state of matter or the place of matter. Again, mass doesn't change by changing the place of matter. If your mass on the earth equal 50 kilogram on the earth, it will be equal 50 kilogram to on the moon. It will be 50 kilogram on any place of the universe, on Jupiter, on Mars, on the sun, if it's possible. يعني لو ممكن حد يروح عند الsun. Okay, so again we can say mass doesn't change by changing the place of matter, whatever this place, mass doesn't change. Okay, another property of mass. Mass of any matter is fixed or stable value. ممكن أقول إن الماس fixed or stable value, and it doesn't change by changing what? State of matter or place of matter. Again, in this property we collect the third and the fourth property. وهنا جمعنا الخاصية الثالثة والرابعة للماس. Mass of any matter is fixed or stable or constant value, يعني قيمة ثابتة, and it doesn't change by changing the state of matter or the place of matter. Okay, again, mass of any matter is fixed, stable value, and it doesn't change by changing the state of matter or the place of matter. Okay, mass is measured by what? What units of mass? We have studied them in primary 4 in science, and also we have studied them, I think, in primary 3 in math. Okay, we have units such as gram for very small units, or for very small objects, kilogram for larger objects, ton for more larger objects. So we have 3 units of measuring mass, which are gram, kilogram, and ton. Gram, kilogram, and ton, they are the units that are used to measure mass. Again, mass is measured in units of gram, kilogram, ton. Mass is measured in units of gram, kilogram, and ton. another property of matter, or the last property of matter, or the last point of matter, mass is measured by devices called scales or balances. ازاي بحدد الماس او ازاي بقيسها؟ عن طريق اجهزه هنسميها scales او balances، اللي سميت خطأ الموازين، لان الموازين يبقى انا بحدد بيها الوزن او الويت. هنا اقدر اقول عليها جهاز تحديد الكتله لو عايزين دقه في اللغه العربيه يعني. اوكي. So again, mass is measured by devices called scales or balances. Scales or balances, they are the devices or the tools that are used to measure mass. يبقى درسنا كويس قوي كل البروبرتي الخاصة بالماس، متهيألي كده تقريبا خلصناها. We know that mass is the amount of matter in the body. We know that mass increase when the matter increase. We know that mass doesn't change by changing the place or the state of matter. We know that mass is measured by units of gram, kilogram, and ton. Mass is measured by devices at this last point called scales or balances. So what are these scales or balances? هل كلها the same؟ هل كل البالانسز أو السكيلز نفس الشكل أو نفس الاستخدام؟ No. We can divide the scales or balances into two types. So types of balances or scales are two-arm scale. two-arm scale هنا هقول عليه ميزان ذو كفتين، مش هقول بقى ميزان ذو ذراعين، يبقى هنا two-arm أقصد بيها ميزان ذو كفتين. two-arm scale. And this two-arm scale we have two examples of it, like balance scale الميزان المعتاد، البالانس scale أو هنسميه ميزان المعتاد أو ميزان ذو كفتين. sensitive two-arm scale الميزان ذو كفتين الحساس هنسميه sensitive two-arm scale. الأذر تايب أو النوع التاني one arm scale الميزان ذو الكفة الواحدة، وده برضه هاخد منه two examples. one arm digital scale one arm digital scale ميزان ذو كفة واحدة رقمي، وهنشوف صور حالا كلهم ليهم دلوقتي. one arm scale with a pointer يعني ميزان ذو كفة واحدة لكن ليه مؤشر. Okay. So now I have a picture for one arm digital scale. one arm digital scale الميزان ذو الكفة الواحدة الرقمي. And this scale is very accurate. ميزان دقيق جدا. And it's used for measuring very large precious in price الحاجات الغالية جدا في الثمن such as gold, silver, platinum, jewels, chemicals, and so on. So again, one arm digital scale is used for measuring precious things like gold and silver. Another picture, one arm scale with a pointer الميزان ذو الكفة الواحدة اللي ليه مؤشر, and we use it for measuring the mass of fruits or vegetables, fruits الفاكهة أو vegetables الخضروات. Again, we have two examples of one arm scale which are one arm scale with or one arm digital scale, and the other one is one arm scale with a pointer, Okay, so now we can summarize all the types of balances in this picture. We have two types of scales. Number one, two-arm scale. Number two, one-arm scale. One-arm scale is divided into two examples, one-arm digital scale and one-arm scale with a pointer. But what about two-arm scale? There are two examples also. Balance scale أو الميزان ذو الكفتين, and sensitive two-arm scale. Okay? So now, nota bene, ملاحظات مهمة جدا جدا about mass. احنا قلنا من شوية إن الماس is the amount of matter in the body, and the mass doesn't change by changing the state or the place of matter. So what are these nota bene? ايه هي الملاحظات اللي هنتكلم عنها أو هنتكلم فيها عن الماس؟ We use the suitable balance to measure the suitable quantity of masses. يعني بستخدم الميزان المناسب للكتلة المناسبة. For example, if I want to measure the mass of gold and silver, لو عايز أحدد كتلة gold و silver, I will use digital scale or sensitive two-arm scale. If I want to measure the mass of fruits and vegetables, لو عايز أستخدم ميزان يحدد لي كتلة الفروتس أو vegetables, I will use balance scale or one-arm scale with a pointer. يبقى مهم قوي نعرف إني بستخدم suitable balance الميزان المناسب to measure the suitable quantity of masses. الميزان المناسب للكتلة المناسبة. Okay. Another nota bene, ملاحظة مهمة جدا. What's different between gram, kilogram, and ton? عشان يبقى عندي sense بالجرام والكيلوجرام والطن, I must know that 1 gram equal the mass of 1 paper clip. ال 1 جرام ده تقريبا بيساوي كتلة دبوس الورق أو دبوس الخاص بالدباسة مثلا يعني. For example, I will use it. I will use gram for very small masses. بستخدمه للكتل الصغيرة جدا like jewelry or like jewels, gold, silver and chemicals or medicines. Okay, I use gram for very small, very small masses such as jewels, مجوهرات, gold, الذهب, silver, الفضة, chemicals or medicines, الأدوية أو الكيماويات اللي بحتاج بيها كميات very precious دقيقة جدا. So again, 1 gram equal the mass of 1 paper clip. 1 gram equal the mass of 1 paper clip. So what about 1 kilogram? What about 1 kilogram? I think 1 kilogram equal 1000 gram. We know that from mass. درسنا قبل كده في الماس ان ال 1 كيلوغرام equal 1000 جرام. ودايما كلمه كيلو او البريفكس كيلو يدي كده انطباع ان هو 1000 الحاجه اللي بعدها. For example 1 kilogram 1000 gram, 1 kilometer 1000 meter and so on. Again 1 kilogram equal 1000 gram and this is the mass of 1 liter of water. دي كتله لتر ميه at the normal temperature. يبقى again 1 kilogram equal 1000 gram and this is the mass of 1 liter of water at the normal temperature. يبقى عشان افرق بين الجرام والكيلوغرام, gram is the mass of paper clip. الجرام هو كتلة دبوس ورق او دبوس صغير جدا, دبوس الابرة يعني. But 1 kilogram is the mass of 1 liter of distilled water. كتلة لتر مقطر من المية النقية جدا. يبقى again تاني مهم قوي اعرف ان ال 1 gram is the mass of 1 paper clip. 1 gram is the mass of 1 paper clip, as we said. 1 gram is the mass of 1 paper clip for small masses as jewelry. But 1 kilogram equal 1000 gram, and this is the mass of 1 liter of distilled water at the normal temperature. So now, kilogram is suitable for what? Kilogram is suitable for measuring large masses, كتل كبيرة, such as fruits and vegetables, Okay, so but what about gram? Gram is used for very small masses such as jewels, gold, silver, and as we said, medicine and chemicals. Okay, so now what's about ton? طب ايه ton بقى? Ton is 1000 kilogram. Ton is 1000 kilogram. So ton is used to measure very big masses such as huge blocks of iron, such as cars, the cargo of cars. يعني حمولة العربيات بنقيسها بالطن because it's very huge masses and we use ton for these huge masses. Okay? يبقى زي ما درسنا عندنا 3 units for measuring mass. They are gram, kilogram and ton. They are gram, kilogram and ton. Okay? So now mass of a body. This is very important example. Example مهم جدا. If the mass of your body equal 50 kilogram on the earth, it will be also 50 kilogram on the moon, so we can say that mass of a body doesn't change from place to place. Mass of a body doesn't change from place to place. الماس ما بتتغيرش من مكان لمكان. الماس ثابتة. Again نقطة مهمة جدا في درس النهاردة. Mass of a body doesn't change from place to another or from place to place. Okay? So example, if mass of your body on the surface of the earth is 50 kilogram, so what do you expect your mass on the surface of the moon? Can you think now? Again, if your mass on the surface of the earth equal 50 kilogram, can you expect, هل تتوقع, what's your mass on surface of the moon? Yes, I can hear you, that's right answer, because your mass equal 50 kilogram. Why? They are the same, because we said mass doesn't change, because mass is a constant value or stable value that doesn't change by changing the state or the place of matter. Okay, so again, mass of your body on the surface of the earth equal 50 kilogram. So the mass of your body on the surface of the moon equal 50 kilogram too. Why? Because mass doesn't change by changing the place or the state of matter. Okay, so now we will study the second half. ندرس الجزء الثاني من درسنا what's meant by weight. يبقى درسنا كويس قوي what's meant by mass. نتكلم عن الويت بالتفصيل. طب نلخص مع بعض اللي قلناه عن الماس عشان ما ننساش. اوكي نكتب مع بعض. Mass, I have a very important definition. Mass is the amount of matter of the body. Is the amount, again, mass is the amount of matter in the body or the object. Okay, that's the definition of mass. Again, mass is the amount of matter in the object. Okay, so now mass has very important properties like that. Mass doesn't change. Mass doesn't change by changing what? By changing the state of matter or the place of matter. Again, mass doesn't change by changing the state of matter. The state of matter. حالة المادة, because we said all matters have mass whatever their physical state, solid, liquid, or gas. State of matter or the place of matter. Again, mass doesn't change by changing the state of matter or the place of matter. So we have many properties of mass. We have studied 2 properties up to now. طب what else? ايه تاني اقدر اتكلم فيه عن الماس؟ We can say that mass increases. الماس بتزيد. Mass increases when matter increases. And we said that قلنا ان هنا relation هنسميها direct relation او علاقة طردية. Again, mass increase when the amount of matter increases. Mass increase when matter increases, and this is a direct relation. Units of mass. What are the units of mass? Units of mass are gram, kilogram, and at last ton. Again, kilogram, and ton. So what are the devices of measuring mass? Device of measuring mass. We have many devices such as, we can divide them into types, which are 2-arm scale, 2-arm scale, 1-arm scale, and we have studied 2 examples of each one of them. 2-arm scale الميزان ذو الكفتين, and we have studied balance scale and sensitive 2-arm scale of the 2-arm scale, and also we have studied 2 examples of 1-arm scale, which are 1-arm scale with a pointer and 1-arm digital scale. 1-arm digital scale. So now what's meant by width? ايه هو الويت؟ عشان نفهم كويس ايه هو الويت لازم اتخيل يعني ايه هو قوة الجاذبية او الجرافيتي او الشد. Imagine that someone like a person of third grade primary school push or pull you from your hand, and another huge one which is like the huge sport, يعني شخص مصارع كبير جدا pulled you from the other hand. هتخيل ان في شخصين بيشدوني، واحد بيشدني من ايديا اليمين، ده شخص صغير شويه في برايمري 3 مثلا او كي جي، وشخص تاني مصارع كبير بيشدني من ايديا الشمال. Which one will pull you more stronger? I think the stronger one or the bigger one. Why? Because the attraction force here, قوة الجذب هنا أكتر شوية. طب يعني إيه علاقة دوت بالويت؟ weight definition مهم جدا. Weight is the attraction force that the body is attracted to the earth. يعني weight هو قوة الجذب اللي بتشدني للأرض. يعني مش مرتبط خالص بجسمي أنا من جوه أو بالماتر اللي جوايا أنا، لكن مرتبط بالماس of the planet. عشان أفهمها أكتر example مهم قوي to differentiate between the difference between weight on the earth and weight on the moon. Imagine that this is the earth, and we know that earth is much bigger than the moon, and this is the moon. Which one is bigger, the earth or the moon? I think the earth. So if I stand here on the earth, I will have weight. If I stand on the moon, I will have less weight. يعني معنى كده ان المون بيشدني بقوة اقل من الارض، يبقى المون بيشدني بويت اقل. For example, if weight here is 600 Newton, weight here will be also, or will be, sorry, less than this and will be 100 Newton only. Why this difference? ليه الفرق بقى كبير قوي كده بين الويت عند الإيرث وويت عند المون؟ Because the earth is much larger or much larger than the moon, and the earth and the moon is much smaller. يبقى دايما الجسم الأكبر هيشد بقوة ويت أكتر. So the weight here on the earth equals 600 Newton, but the weight on the moon equal 100 Newton. So again, the main difference, الفرق الرئيسي بين الماس والويت, the main difference between mass and weight. Mass doesn't change, as we said and as we studied, but weight changes by changing the place and changes by changing the planet that we are on. For example, if I imagine that, هتخيل معاكم ان انا هروح لجوبيتر, the largest planet. If someone puts his leg on Jupiter planet, he will be died soon. Why? Because on Jupiter the attraction force or the weight equal 11 times at the Earth. يعني عند جوبيتر قوة الجاذبية تقريبا 11 مرة قد الأرض. So I can't bear, مش هقدر أتحمل خالص القوة ديت. So again, God created the man or the people on the earth. Why؟ ليه ربنا خلقنا على الأرض تحديدا؟ Because it has a suitable gravity. الجاذبية مناسبة جدا. We can live without peering بدون أي or without suffering بدون أي معاناة. But on the moon we can't live. Why? Because on the moon we will like flying يعني هتحس كده ان احنا بنطير او مش قادرين نمشي كويس قوي عند المون. Why? Because the gravity on the moon is less than the earth. في ناس كتير بتعتقد بعض الطلبه ان عند المون مفيش جرافيتي، لا هو فيه بس الجرافيتي قليله شويه. يبقى عند المون في جرافيتي but less than the earth. or في في وزن عند المون but less than the earth. So now we can summarize the main difference between mass and weight. Mass doesn't change and the mass is the amount of matter in the body. هي كمية المادة اللي في جسمي أنا. Like the blood, like the muscles, like the bone and so on. But weight is the attraction force that the body is attracted to the earth أو by which the body is attracted to the earth. هي قوة الجذب اللي بينجذب بيها الجسم للأرض. يبقى هي مرتبطة بالبلانيت اللي أنا موجود عليه، الكوكب اللي أنا عايش عليه. For example the earth, Mars, Jupiter, Saturn and so on. طبعا عارفين كويس قوي إن مفيش أي لايف إلا على كوكب ايرث، لكن هتخيل لو في حد راح عند اي كوكب تاني يبقى الجرافيتي او الويت هيتغير. Why? Or because the size or the volume of the planet will be changed. Okay? ناخد example يوضح اكتر the difference between weight on the earth and on the moon and on Jupiter planet. Which one is bigger? We know that Jupiter is the largest planet. Jupiter. Okay? Earth is much smaller than Jupiter. Okay, Moon is much smaller than both of them. Imagine that if a person is standing here on Jupiter, he will have weight 6,600 Newton. But on Earth, the same person will have 600 Newton only. 600 Newton only. But on the Moon, he will have 100 Newton only. Why? Because Jupiter is much larger than the Earth and the Moon. He will have attraction force. كأنه شخص كبير جدا أو قوي جدا بيشدني قوي، فهنا عندي weight عالي جدا أو attraction force عالية قوي. So Jupiter has the largest attraction force of all the planets because Jupiter has the largest size. But what about the Earth and the Moon? Earth has medium attraction force or medium gravity because Earth has medium size relative to the Jupiter or Jupiter planet and the Moon. But what about the Moon? Moon has the least attraction force or the least weight because it has very small size compared to the Earth and the Jupiter planet. So now we can have a definition for weight. What's meant by weight? I think weight will be is the gravitational force by which the body is attracted to the Earth. Again, weight is the gravitational or the attraction force by which the body is attracted to the Earth. And the main difference between mass and weight is that mass changes or doesn't change, as we have studied. Yes, you very good, right? Mass doesn't change. But what about weight? Weight changes because weight depends on the place I will stand on, depend on the mass of the planet I live on, and also many things that the weight depend on. Okay? يبقى زي ما درسنا كويس قوي ان الماس ما بتتغيرش, doesn't change, but weight changes according to the place I live on or according to the place I stand on this moment. Okay, so again, definition of weight. Weight is the gravitational force by which the body is attracted to the Earth. Okay, so now what are the properties of weight? زي ما درسنا كويس قوي properties للماس, اخد كمان properties للويت. نرجع تاني نقول definition للويت. Weight is the gravitational force by which a body is attracted to the Earth. Okay, again, weight is the gravitational force by which a body is attracted to the Earth. What are the properties of weight? Number one, the effect of weight is always directed towards the Earth's center. دايما تأثير الويت متجه لمركز الأرض. The effect of weight يعني مفيش حاجة بتقع لفوق أو يمين أو شمال. أي حاجة بتقع للأرث center. يعني تخيل كده لو أنت ماسك for example a pen or a pencil and you leave it, it will surely fall to the Earth's center. Surely it will fall to the Earth. Why? Because the effect of weight is always directed towards the Earth's center. Okay? دايما تأثير الويت متجه لمركز الأرض, وده معناه إن أي حاجة بتقع لتحت للأرض مش لفوق. Okay? Again, the effect of weight is always directed towards the Earth's center. On Earth, all objects have weight. على الأرض كل حاجة ليها weight. كل الأشياء ليها weight. But in space, في الفضاء بقى all objects are in a state of weightlessness. الفضاء بيبقى في حالة اسمها weightlessness أو انعدام الوزن أو انعدام الجاذبية. ليه؟ Because in space we have no weight، ما عندناش weight أو we have no gravity، مفيش جاذبية بتشدني. أنا خرجت بره نطاق الجاذبية أو بره المجال اللي ممكن يبقى فيه جاذبية للأرض، ففي الحالة دي هنسميها weightlessness. imagine that. نرسم مع بعض عشان نتخيل يعني إيه weight ويعني إيه weightlessness. هتخيل إن دي الإيرث بتاعتنا. اوكي، نرسم مع بعض ايرث، وهتخيل تاني ان في حاجه اسمها اتموسفير، وده ان شاء الله هدرسه بالتفصيل in details in prep 2. اتموسفير بتاعنا او الغلاف الجوي اتموسفير. اوكي، هنا في الاتموسفير او في اي مكان في الاتموسفير دوت I have weight. I have weight. Why? Because I have gravity. Because I have gravity. But outside the atmosphere I have weightlessness يعني انعدام الوزن. Why I have weightlessness? Because there is no gravity. لأن مفيش gravity، ده خارج الجاذبية الأرضية أو خارج الغلاف الجوي. So I have weightlessness، هيكون في حالة اسمها انعدام الوزن. And we can see this in some pictures of the space astronauts، رواد الفضاء. They are like flying، كأنهم بيطيروا and they must be tied to the space suit by some ropes. لازم يكونوا مربوطين كويس قوي ببعض الأحزمة أو الحبال للسبيس suits أو للسبيس شيب، سفن الفضاء. And again we have weight on the earth and we have weightlessness on the space. Again بيكون عندي weight وأنا فقط على الأرض، لكن في حالة في الفضاء أو في انعدام الجاذبية بيبقى عندي حاجة اسمها weightlessness أو انعدام الوزن. weightlessness أو انعدام الوزن. Okay. Another property of weight, the measuring unit of weight is Newton. عشان نكرم الشخص أو العالم اللي عمل أو اكتشف يعني إيه weight أو يعني إيه gravity، زي ما عارفين أو قرينا قبل كده في دروس القراءة مثلا، اسمه إيزاك نيوتن أو إسحاق نيوتن، ده عالم مشهور جدا وهو اللي اكتشف الجرافيتي أو الويت. خدنا اسمه خليناه يونت للميجرينج ويت. طب حد يفكرني كده what are the measuring units of mass? Surely we have studied 3 measuring units of mass that are gram, kilogram, and ton. Gram, kilogram, and ton. They are the measuring units of mass, but we have only one measuring unit for measuring weight, which is Newton. يبقى عندي 3 units للmeasuring mass. They are gram, kilogram, and ton. لكن في واحدة بس للويت هي نيوتن اللي استخدمناها عشان نكرم او نخلد ذكر العالم إيزاك نيوتن او إسحاق نيوتن. So again we have 3 measuring units of mass which are gram, kilogram, and ton, but only we have one measuring unit for weight which is Newton. Another property of weight, Newton equal what? Newton ده بيساوي قد ايه تقريبا؟ Newton equal the weight of mass of 100 gram. يعني لو عندي كتلة mass equal 100 جرام، الويت بتاعها هيساوي تقريبا 1 نيوتن. Again 1 نيوتن equal the weight of mass 100 gram. So again I have some problem about this. If I have 1 Newton equal 100 gram. Okay, so if I have 500 gram equal what Newton? I think it will be 5 Newton. If I have 10,000 gram, which is 1 kilogram, it will be 10 Newton. So I can say that أقدر أكتب كويس قوي باختصار شديد إن 1 kilogram equal 10 نيوتن. وهي دي الريليشن ما بين الماس والويت. بعد شويه هدرس قانون مهم جدا عشان احول من الماس للويت او الويت للماس، اني هعمل مالتيبلاي الماس باي 10 عشان يديني الويت. Again 1 كيلوجرام equal 10 نيوتن. 1 كيلوجرام equal 10 نيوتن but 1 نيوتن only equal 100 جرام. نرجع تاني ونتكلم عن ال properties of weight and we have studied that the weight is the attraction force أو قوة الجذب. والويت مش مرتبط بالماس اللي جوايا قد ما هو مرتبط بالبلانيت الموجود عليه أو الكوكب اللي موجود عليه. يعني مين اللي بيشدني؟ مين اللي بيعمل attraction force؟ هو ده معنى الويت أو الجرافيتي، الوزن أو الجاذبية. وعلى فكرة كتير قوي بعض الكتب العلمية لما نقرا كلمة جرافيتي أو الجاذبية هي the same meaning of weight، هي نفس معنى الوزن. يبقى كده فرقنا كويس قوي بين الماس والويت. الماس الكتلة is the amount of matter in the body، لكن الوزن هو ال attraction force أو gravitational force. attraction force أو gravitational force. So again another property of weight. The measuring device of weight. ايه هو الجهاز اللي هقيس بيه الويت؟ جهاز هنسميه spring scale. spring scale هو الجهاز الوحيد اللي هقدر استخدمه عشان احدد بيه الويت، لكن عندي اكتر من جهاز بستخدمه للماس. دايما كده الماس فيها استخدامات كتير قوي وليها اكتر من يونت واكتر من جهاز، لكن الويت هو جهاز واحد بس اسمه spring scale. Again, the measuring device of weight is the spring scale. اوكي، ودي picture او image للspring scale. ده شكله بيكون فيه هوك خطاف وبعلق فيه اي حاجه عايز احدد لها الويت، وفي هنا بوينتر مؤشر بيحدد لي الويت accurately. Again بيكون فيه هوك خطاف زي ما احنا شايفين من تحت كده، بيحدد لي كويس قوي عن طريق البوينتر او المؤشر ده الويت بتاع الجسم اللي انا بتكلم عنه. So again, I used the spring scale to measure the weight of matter. But I have many devices for measuring mass, as you know, 2-arm scale, 1-arm scale, and so on. Again, هنا بتكلم عن السبرينج سكيل، ده ميزان وحيد لقياس الوزن أو الويت. Spring scale is used for measuring weight. Spring scale is used for measuring weight. Okay? So weight of any body increases by increasing its mass. Surely, when I increase mass, the weight increases. Again, when I increase the mass, the weight increases. And this relation is called direct relation. دي هنسميها علاقة طردية برضه. يبقى النهارده خدنا two relations، العلاقة بين الماس والماتر direct relation، والعلاقة بين الويت والماس برضه direct relation أو علاقة طردية. هنسميها direct relation يعني علاقة طردية. So factors affecting weight. احنا اتفقنا ان الماس doesn't change. So mass has no factors. الماس ما عندهاش اي factor، لكن الويت عنده factors او عوامل بتأثر عليه. Again, factors affecting on weight are number 1 the object's mass، كتلة الجسم. The object's mass where the weight increased by increasing the mass. Imagine that. يعني نشرح مع بعض شوية بشكل أفضل شوية أو بشكل مبسط شوية. If I have a mass equal 50 kilogram. Okay, they have a mass equal 50 gram. Its weight will be what? We agreed that اتفقنا عشان اجيب الويت هعمل by 10. It will be 500 newton. If mass equal 60 kilogram, so the weight equal 600 newton. If the mass equal 100 kilogram, the weight equal 1000 newton. So what happened to mass? Mass increases from 50 to 60 to 100. What happened to weight? Weight also increases from 500, 600 to 1000. Increase also. So I can say that when mass increases, weight increases. Okay? So the relation between mass and weight also is direct relation أو علاقة طردية. Again, the relation between mass and weight is direct relation or علاقة طردية، يعني الاثنين increase مع بعض. Increase or decrease. Again, the first factor يبقى أول عامل بيأثر على الويت هو الماس. And the relation between them is direct relation or علاقة طردية. So again, where the weight increases by increasing the mass. Again, the relation between mass and weight is direct relation or directly proportional. ودي هنسميها علاقة طردية، يعني لو الويت increase الماس برضو increase. The other factor that affecting weight is the planet or the place where the object exists. وشرحنا من شوية قلنا كل لما ال place increase أو ال planet increase in size, the attraction force increase. So let us see. Where the weight increases by increasing the planet mass. Where the weight increases by increasing the planet mass. So again, نشرح بشكل أفضل شوية. I have two planets like this. Planet A and planet B. Which one is bigger? I think planet A. If one is standing here, في شخص have weight here, for example, 600 Newton. And the same person is standing here, he will have less weight or more weight. I think he will have less weight, so his weight is equal P, like 100 Newton only. Why 600 decrease to 100? Because here the planet size increase. So when the planet size increase, I can write this. When the planet increase, what happened to weight? I think we can write that weight increases. يبقى العلاقة بين البلانيت والحجم أو حجم البلانيت حجم الكوكب والويت برضو directly proportional أو علاقة طردية. Increase or decrease. Increase or decrease. Okay? So again, the planet or the place where the object exists affects the weight, where the weight increases by increasing the planet mass. Again, the weight increases by increasing the planet mass. The last factor العامل الأخير والثالث اللي بيأثر على الويت is the distance between the object and the center of the planet. هو المسافة بين الشيء اللي بتكلم عن وزنه ومركز الكوكب. Again, the distance between the object and the center of the planet. Okay? Where the weight decreases. هنا بقى الوزن هيقل. ده فاكتور مختلف شوية عن كل اللي فاتوا. Where the weight decreases when the distance between the object and the center of the planet increase. Imagine that. نتكلم بشكل أفضل شوية. If I have the Earth's planet like this, عندي كوكب الأرض, and I have the equator, خط الاستواء, and this is the center of the Earth. If someone is standing here, لو شخص واقف هنا, and this someone, نفس الشخص, departed, رحل وراح to the pole, يعني راح للقطب الشمالي تقريبا, North Pole. هنا هيكون عنده تقريبا, for example, 500 نيوتن, لكن فوق هيبقى عنده أقل شوية تقريبا هيبقى 490 نيوتن. Why this difference? Because when the distance between the planet decrease, or sorry increase آسف, لما المسافة بتزيد الويت بيقل. هنا علاقة عكسية أو هنسميها inverse relation. علاقة عكسية أو هنسميها inverse relation. So I can say that when the distance, لما المسافة from the center increases, المسافة هتزيد. What happened to weight? What happened to weight? Weight decreases. أول مرة آخد حاجة زي كده النهاردة. كنت متعود إن كل مرة بقول على relation direct، هنا هقول inverse relation أو هنسميها indirect relation. علاقة عكسية. inverse relation. يعني كأني بتخيل كده لو في شخص جنبي قريب شوية، المسافة بيني وبينه قليلة، يبقى قوة الشد عالية جدا، بقدر أشده بسهولة. لكن لو شخص بعيد شوية هيبقى قوة الشد ضعيفة شوية. So when the distance increase، لما المسافة بتزيد، what happened to weight? Weight decreased. Weight what? Weight decreased. يبقى when the distance between the planet center and the object or the body I want to measure its weight increases, the weight decreases. So the relation between the distance and weight is the inverse relation or inversely proportional. So now we have studied three factors that affecting weight. What are they? كده درست ثلاث عوامل بيأثروا على الويت. The first factor is the mass, and the mass increase when the weight increase, and vice versa. The second factor is the place or the planet, and we know that when the planet size increase, كل ما الكوكب بيكبر, the weight increase too. And also we have studied the third factor about which is the distance between the center of the planet and the weight. And we also studied that the relation between them is inversely proportional, يعني علاقة عكسية, because when the distance increase, لما المسافة بتزيد, the weight decrease as we know. Okay? Again, when the distance increase, the weight decrease. And as we know, this is called inverse relation أو هنسميها علاقة عكسية, increase decrease or decrease increase. Okay, now we have nota bene, ملاحظة مهمة جدا about weight. Okay? The attraction force, as we have studied, attraction force on an apple, its mass 100 جرام. يعني لو في تفاحة ليها mass 100 جرام يبقى الفورس بتاعتها أو الويت بتاعها 1 نيوتن. طب لو في mass of 200 جرام يبقى attraction force 2 نيوتن and so on. Okay? Weight affects towards the Earth's center. الويت دايما بيأثر على مركز الأرض أو بيأثر في اتجاه مركز الأرض. دايما الويت ليه direction لكن الماس has no direction. As we have studied زي ما درسنا, الماس doesn't change by changing the place or by changing the state of matter. But weight changes. الويت بيتغير عشان كده بيأثر دايما في اتجاه مركز الأرض Earth's center. Weight increases by increasing the mass as the following relation. الويت دايما بيزيد كل ما زود الماس كالعلاقة التالية. إيه هي؟ weight equal mass in kilogram by 10. وده قانون مهم جدا هدرسه إن شاء الله أو هنتكلم عنه بالتفصيل لما نتكلم عن solving the problem أو حل المسائل. weight equal mass in kilogram by 10. weight equal mass in kilogram by 10. or mass equal weight divide 10. يبقى ممكن من خلال مثلث واحد بس أجيب الويت أو الماس. طب نتكلم إزاي عن المثلث دوت؟ نرسم مع بعض مثلث درسناه في الماس قبل كده. نرسم مع بعض. اوكي. I have weight here. هنتكلم دلوقتي عن المثلث، العلاقة بين الويت والماس في حل أو solving problem، حل المسائل. weight وهكتب هنا تحت الماس by 10. So if I want weight, so weight equal what? weight equal mass by 10. اوكي. يبقى هنا بالظبط في المثلث ده الحاجة اللي أنا بحب أخدها في المسائل أو بحب أحلها بحط القلم عليها. If I want mass, weight, it will be mass by 10. If I want mass, it will be weight divide 10. weight divide 10. Okay? If I want mass, it will be weight divide 10. So again, I must keep this triangle لازم اكون مذاكر كويس قوي المثلث ده عشان اعرف احل problems. I have width on the above edge على الحافه اللي فوق. I have mass and 10 at the bottom. If I want width equal what? Equal mass by 10. If I want mass equal width divide 10. Mass equal width divide 10. Okay? So now let's study a very important and very easy example. لازم ناخد بالنا كويس قوي ان surely ان شاء الله هيكون في problem في ال last examination عشان نحله. لازم اكون كويس قوي عارف ايه هو الرول او هو القانون اللي اقدر اشتغل بيه. زي ما اتفقنا هو مثلث واحد بس width mass by 10. If I want width equal what? Equal mass by 10. If I want mass equal width divide 10. So now let's study an example for solving the problem about mass and width. Okay? Okay. The problem says that a body weight on the surface of the earth equal 6 Newton. Will be what on the surface of the moon. هو هنا قال لي will be 1 Newton on the moon. طب ازاي اتحلت المسألة ديت؟ نكتب مع بعض ونشوف نحل ازاي البروبلم about mass and weight. هو قال لي ان الويت on the moon on the surface of the earth equal 6 Newton. Okay? طب عشان اجيب الويت on the surface of the moon I have another rule. عندي قانون تاني مهم جدا. ايه هو؟ هنا هكتب weight بس هكتب تحتها بخط صغير شوية E like the earth. يعني هو يعني الاي دي بيعبر عن الارض. هنا weight on the moon برضو بحرف صغير شوية او بخط صغير M by 6. So if I want the weight on the moon equal weight on the earth divide 6. So if the weight on the earth as an example equal equal 6. So weight on the moon equal 6 divide 6. So it will be 1 Newton. Again, how come this problem ازاي جت 1 نيوتن على المون؟ احنا اتفقنا ان الويت on the moon equal 1 over 6 on the weight of the earth. يعني لو الويت عند الارث for example 60 نيوتن، الويت عند المون هيبقى 10 نيوتن. Why? Because we divide by 6 to obtain the weight on the moon. Okay? We divide by 6 to obtain the weight on the moon. So again نرجع تاني نقول the weight of the body on the moon equal 1 over 6 from the weight of the body on the earth. Why? Because as we know مين أكبر في الاثنين؟ earth ولا المون؟ اتفقنا ان الارث أكبر كتير جدا من المون. So the weight on the earth will be larger than the weight on the moon. So again we can say that the weight of a body on the surface of the moon equal 1 over 6. We can divide by 6 directly. يعني موضوع سهل جدا. عشان اجيب الويت عند المون هعمل divide 6 directly. So I will obtain the weight on the moon from the weight on the earth. Okay. again كده عندي two rules مهمين جدا عشان احل بيهم مسائل الماس والويت. الرول الاول خاص بالويت والماس weight on the earth and the mass and we know that mass doesn't change. يبقى لو في problem فيها mass وقال لي for example mass on the earth 30 كيلوغرام. طب mass on the moon equal 30 كيلوغرام. ليه؟ because mass doesn't change. يبقى ناخد بالنا كويس قوي في تريك بنقع فيها كلنا. لو الماس عند الارث for example 40 كيلوغرام يبقى الماس عند المون 40 كيلوغرام. ماس في اي مكان 40 كيلوغرام حسب الاكزامبل اللي هو قاله لي. اتفقنا؟ because mass doesn't change. نرجع تاني ونقول ايه الرولز بشتغل بيهم نكتبهم مع بعض. انا عندي تو رولز. الرول الاول انا بحب اسميه weight وماس. weight وماس by 10. الرول التاني او القانون التاني weight weight. What difference? Weight on the earth, weight on the moon by 6. So here from this first rule I want weight. If I want weight equal mass by 10. If I want mass equal weight divide 10. Second rule, if I want weight on the earth equal weight on the moon by 6. Okay? If I want weight on the earth, weight on the moon, sorry, equal weight on the earth divide 6. Okay? Weight on the earth equal weight on the moon by 6, but weight on the moon equal weight on the earth divide 6. Okay? So again, weight on the earth equal weight on the moon divide by 6, sorry, but weight on the moon equal weight on the earth divide 6. Okay? So now I have two important rules. قانونين مهمين جدا للماس والويت او الويت on the earth and weight on the moon. لازم كويس قوي اعرف شكل المثلث عشان احدد انا هشتغل باي قانون فيهم وهعرف اشتغل ازاي. ولازم احدد كويس قوي انا عايز ايه في القانون ده. هل عايز weight؟ هل عايز mass؟ weight on the earth؟ weight on the moon and so on. Okay? Okay, so now let's have an example for solving the problems of mass and width. Or before this example, I want to make a summarize. عايز أعمل ملخص الدرس كله. Compare between mass and width. نعمل مقارنة بين الماس والويت. ولو فهمنا كويس قوي الكومباريزون دي يبقى كده الدرس يعني استوعبناه بشكل حلو جدا، وأتمنى أن يكون ده حصل لكل الطلبة. Okay, so now compare between mass and width. Okay. At first, I must compare between them in definition. We have a definition for each one of them. Mass is the amount of matter in an object. As we know, mass is the amount of matter in an object. But weight is the gravitational force by which a body is attracted to the earth. Again, the definition between mass and weight. Mass is the amount of matter in an object, but weight is the gravitational force by which the body is attracted to the earth. يبقى أول مقارنة هتكلم فيها عن الماس ويت، أو أول point of comparison هتكلم عن definition. هتكلم بعد كده عن units. We have 3 units for measuring mass: gram, kilogram and ton. gram, kilogram and ton. لكن في unit واحدة بس موجودة عند الويت هي نيوتن. Again, we have 3 units for measuring mass: gram, kilogram and ton. But I have only 1 unit for measuring weight, which is Newton. Okay, we have also measuring tools. النقطة الثالثة اللي هتكلم فيها أو البوينت اوف كومباريزون الثالثة، measuring tool أو وحدات الأجهزة اللي هقيس بيها الماس. عندي أكتر من جهاز: 2 arm scale، 1 arm scale. لكن الويت عندي جهاز واحد بس هو spring scale أو الميزان الخاص بالويت، هو اسمه spring scale. اتفقنا؟ يبقى عندي أكتر من جهاز لmeasuring mass أو الويت spring scale. And also I have the direction and the effective force. يعني direction of mass. Mass has no direction, but weight is towards the Earth's center. So by this comparison, my dear students, we have reached the end of this episode. I wish you every possible luck, and goodbye, and see you soon.